Okay, 10.4 was all all addition and subtraction, which said that everything had to be the same in the radicands, and then you would add and subtract the numbers that were out front with the coefficients. 10.5 kind of goes in a different direction because it's multiplication. Okay, and 10.5 actually is a little bit easier because when you're multiplying radicals or square roots, it says, all right, we don't care. You're just going to multiply everything. It doesn't matter if it's the same or not. If you're multiplying radicals. Now, first thing is the indexes do have to be the same. So just like when we're adding, subtracting, same thing. You're not able to add a third root and a second root. Same thing with multiplying. You can't add a third root and a second root. They both have to be the same index, but that shouldn't be a problem when you go through these. And once you do these, you're going to multiply the coefficients on the outside. Then you're going to multiply your radicands, which is your inside numbers. And then, if you're able to at the end, then you go back and simplify. Okay, so multiplying is a little bit easier. You don't have to worry about everything lining up and being perfect. If you're multiplying radicals, it basically says, all right, just start multiplying. Multiply the outside numbers, multiply the inside numbers, and then see what you get. You know, just kind of break it down and go from there. Okay, so with objective 1, they just give you just straight up easy problems to work with here. So, all right, let's say you had the square root of 7 times the square root of 3. Well, indexes are the same. Outside number coefficient-wise are 1, so we really don't need to worry about that part. We're just going to multiply the radicands on the inside. So if you do 7 times 3, that is 21. And then if you get 21, well, you try to break it down. But if you try to break it down, there's no perfect square roots you can divide out of it. So that would be it. And we'll get some of those on the next objective coming up. So that's objective 2 when I talk about that. The only other thing that they would do is if you get the square root of 5 squared, if that is the square root of 5 times the square root of 5, but 5 times 5 is 25, and the square root of 25 is 5. Now, and probably what they really wanted you to see on this one is that it's kind of along those same lines like we did back in section 3, that if this radicand here, or if this index and this power match up, they're still going to cancel each other out, and you can just do a shortcut and go straight to the end. So if you see some number square rooted to a second power, that square root and that power cancel each other out, and you can just take a shortcut and go to the end. But again, you could always just break it up as the same number times itself and then square root it. And you're always going to come back to this number that's here. So it's kind of a little bit of a shortcut you can go through on those. Okay, so that's objective 1. Should go really quick on those because there's not really much. That's about the only 2 things they'll throw at you. Objective 2 says, all right, well, let's take some numbers that we've got here, and let's get it so that at the end you do have to come back and do a little bit of simplifying. Square root of 6 times square root of 2. Okay, go ahead and do 6 times 2, which is 12. And if you get 12, then hopefully you go, okay, well, 12, you could break that down. Now, you can make it 2 times 6. But again, if they're smaller numbers, start thinking about perfect square numbers that you could divide into it. So 12, you can make it 4 times 3. Well, there's your square root of 4, so you can make that 2. And the 3 stays on the inside, so that would be 2 square root of 3. Okay, square root of 12 times square root of 8. Okay, go ahead and multiply those together. 12 times 8 is 96. And if you start going, well, I can't think of a perfect number that goes into 96, that's fine. You know, sometimes the numbers can just jump out at you. You know, if it's like this, pretty easy. 96, you may not know what perfect number may go into it. It's not really popping off in my head right now either. So this is one you just go back and start taking the 96 and break it down. It's even, so divide it by 2. 2 will go into 96, 48 times? 48's even, so we divide it by 2. 24 is even, so we can divide it by 2. 12 is even, so we can divide it by 2. 6 is even, so we can divide it by 2. Okay, so if we take 96 and break it all the way down, that gave us 2 times 2 times 2 times 2 times 2 times 3. And again, as long as it's square roots, you can kind of go ahead and start pairing them off. There's a pair of 2's we can put on the outside. There's another pair of 2's that we can put on the outside. Those 2's and 3's are left on the inside. So they don't have any exit buddies to get out there. So for this one, 2 times 2 is 4, and 2 times 3 is 6. And again, if you want to go back and just rewrite them all together, you could do that. If you go back and list each individual number. But again, if you start with, you know, if it's odd, if you start with all the 3's and work your way down, most of the time you can kind of pair it together. If they get a little scattered out, just come back and bring it all together. You know, take out the pair of 2's, take out the other pair of 2's, until you get to the end where you've kind of taken everything out and broken up all the exit buddies. Okay, objective number 3. They kind of changed gears on you just a little bit on this one. And again, I can't remember the exact wording they put on this one, but basically they put bigger numbers in the radicals. I mean, it's really what it comes down to. That if, you know, back here we were doing, you know, 12s and 8s and 6s and 4s and 3s and 7s, that kind of stuff where it's pretty short. This is one way to give you bigger numbers. That basically if you get one this where the numbers get bigger and you start multiplying together and you go, whoa, that's getting kind of big. Here's what you want to do first. If you get bigger numbers in the radicands, break down the radicands first. And then you can go back and multiply together. So maybe it's something like this. It's 72 times 2 squared of 18. That if you did 72 times 18, you're up into the, you know, up into 1,000 something now. And most people are like, no, I don't want to do that. So here's what we're going to do. If the numbers are getting bigger, you know, go ahead and take these numbers and start breaking it down. If you start taking the 30, and again, if you're not sure about 72, start dividing it by 2's. 2 will go into 36, or 72 36 times. And maybe you go, wait. If 72 is 36 times 2, 36 is a perfect square root, right? So for that one, you can make this thing, you can take, no, let me back up here for a second. Because that would be 36 times 2. Take 72 and break it down. 36 is that perfect square root number, so that's really just 6 squared of 2. Okay, 2 times 18, you may go, well, maybe 18 times 2 is not that bad. If you want to do that, you can. But 18, if you think about that one, you could break it down. 18, you can make it 9 times 2. So we've got the 2 that's here. If you do the square root of 9, that is 3. Take out that square root of 9 and make that 3. So you've got 2 times 3 times the square root of 2. Well, if you put that together, you've got 6 square root of 2 here. This would also be a 6 square root of 2. So then if you multiply these together, you're going to multiply the outside numbers together. 6 times 6 is 36. Then you're going to multiply the inside numbers together. 2 times 2 is 4. So that's 36 times the square root of 4. And that's 36. The square root of 4 is just 2. So 36 times 2 would make that answer out to be 72. Okay, now that one kind of happened to work out where at the end it all came out to be a nice, perfect square root. Let's give you one where it's not, because I would think more so than not, they're not going to be whole number answers when you get to the end. You should have some number with a whole number with a coefficient and have a radical left over. So I think it's probably going to be more of the second type that we're doing than the first type that we had here. Okay, so we'll do 2 squared of 96 times the square root of 98. Okay, so we've got 2 squared of 96. And again, if you start thinking about this one, you know, it's even. You can divide it by 2. 2 will go into 96 48 times. Not a perfect number, so we'll just kind of keep on going from here. 48, if you divide it by 2, it's 24. 24, if you divide it by 2, that's 12. 12, if you divide it by 2, that's 6. 6, if you divide it by 2, that's 3. Okay, so we had the 2 that was here with the 96, so it's out separate. On the rest of the part, we get a pair of 2's here, so that 2 gets to come out. We've got another 2 that's here, it's pairs, so that number will come out. These 2 don't have any pairs, so they'll stay on the inside. And that 2 is out, that was out front here, it's still hanging out front here. Okay, so we got 2 times 2 is 4, 4 times 2 is 8. So this will become 8 square root of 6. Okay, and then with the 98 that's here, we'll go ahead and start breaking this thing down. Again, if you divide it by 2, if I start, setting this thing up to do this part, I'm thinking 98 divided by 2, that gives me 49. But then hopefully 49, you go, wait, that's a perfect square root number, right? So 98 is really 2 times 49. But you can take the square root of 49 and just make that 7. So this one's 7 square root of 2. Okay, so taking the first 296, breaking it down, it's 8 square root of 6. Square root of 98 became 7 square root of 2. Well, now you've got easier numbers to work with. Now we can go back and multiply this together. So on the outside, we've got 8 times 7 for 56. And on the inside of the square root, 6 times 2 is 12. Okay, 12, you can break that one down a little bit. So we'll hang the 56 out here for just a minute. 12, if you do that, that's 4 times 3. And if you do the square root of 4, that part's just 2. So that would be 2 square root of 3. So you have 56 times 2 times the square root of 3. 56 times 2 would make that out to be 112. Square root of 3. Okay, so when they give you the big numbers, it's bigger numbers, so there's just more work to it. And again, depending on how good your skills are, it's probably easier to break the numbers down first and go with it from there. Okay, so with objective 3, just has you work on those and keep breaking the parts out on this one to kind of get through it there. All right, objective 4. Objective 4, they go kind of back to like we were doing back with add and subtraction. This time they throw some variables in there. So we're still going to be multiplying. We're still going to go through these things on this one, but this time they're going to give you variables when you mix in with this one. Okay, so it's something like the square root of 5x times the square root of 6x. Okay, now, and it still doesn't, it's still the same thing. The only thing you have to remember is that if you're adding, or you're multiplying, you're actually going to add the exponents. So if we've got the square root of 5x times the square root of 6x, you can go ahead and pull those two things together. You know, if you thought about it this way, if you broke them all down and left them just out this way, you'd have 5 times 6, which would be 30. And again, if you have x times x, there's two x's there. So that makes it x squared. Okay, and if you start breaking down the square root of 30, it's one of those numbers that seems like you should be able to simplify it, but if you start breaking down the 30, you know, it's 3 times 10, which is then 2 times 5. There are no pairs, there's no exit buddies in 30 that you can break out, so 30 is just 30. But you do have the square root of x squared. So the square root of 30 is going to stay here because this is the second root. When you take x squared, it does have a pair of buddies, right? It's x times x, so that x will get to go on the outside, so that basically makes it x times the square root of 30. So they're kind of going back to some of the variables and having you think about how they paired up and the numbers that you get with it. But I think the biggest thing really that most people miss on this one is that, remember, if you do some variable times itself, another variable that's the same variable there, you're actually going to add the exponents. And sometimes that kind of slips by, so because you're keyed in on a lot of the other things. That's just one of the little things that will slip by you if you're not, too careful with it. Okay. Now, again, another one of those things that they'll kind of do to kind of sneak one past on you, they may give you like the square root of 7y squared. But again, here's the shortcut on this one. As long as this is the square root, index is 2, that second power and that second index cancel each other out. And once those things cancel out, the answer is just going to be whatever you got inside the square root. That would just be 7y. Now, and again, you could think that this is 7y times 7y. And if you multiplied it together, that would make it 49y squared. But again, if you take the square root of 49, that's 7. The square root and the squared number would cancel and just get you back here. So the easier thing on that one is if they give you something that's squared, as long as it's square root, those two things cancel out. And whatever's on the radicand, that just comes back to get your answer there. All right, one more of those. Square root of 2x times the square root of 5. Okay. And if one has an x, one doesn't, still doesn't matter. You still go ahead and multiply them together. It's just square root of 10x. You break down 10, it doesn't do anything. It gets you 2 times 5, so there's no exit buddies there. You only have the 1x, so there's not a pair of them, so same thing, it doesn't have an exit buddy. So in that case, the answer would just be the square root of 10x, and that's all you can do there. Okay, objective 5. On this one, now they start changing out the variables. So that now you're going to have bigger powers than just the first power. Now you're going to have 3s and 4s and 5s on the x's. So you're going to have bigger exponents on the powers, on the variables. So they're just kind of stepping this thing up one more notch from there. So you're going to have something like 3x to the third times the square root of 6x. And all these numbers, coefficient-wise, all the numbers should be small, so you shouldn't have to worry about breaking any of these down first. These you can just go ahead and multiply together. 3 times 6 is 18. X to the third and x to the first would make that x to the fourth. And then once you get to the end, again, go ahead and start breaking it down. We're going to work on the square root of 18, and we're going to work on the square root of x to the fourth. $18 is 9 times 2. Again, if you take the square root of 9, that part makes that out just to be a 3. And if it's x to the 4th, again, your index is 2, so you're taking 4 and dividing by 2, well, that goes even, right? 2 times. So this comes out to be x squared. And more than likely, they're going to put the 3 and the x squared together because they're outside the radical there. And then the square root of 2 would stay on the inside to get the answer there. So they'll pretty much take everything that's on the square root and put it to the end. Everything that's outside the square root, they're going to pull that together and put that in front of the square root there. Okay, so let's go with square root of 6, a to the 4th times the square root of 8, a to the 5th. Okay, 6 times 8 is 48. A to the 4th and a to the 5th will make that a to the 9th. Okay, and again, once you're here, you're going to break it up into 2 parts. We're going to do the square root of 48, and we're going to do the square root of 8 to the 9th. Square root of 48, start breaking it down. I think we've done 48 a couple of times. If you do it with, start breaking it down with the 2's. It's 2 times 24. 24, you can rewrite that as 2 times 12. 12, you can make it 2 times 6. 6, you can make it 2 times 3. So there's a pair of 2's, so that 2 will go on the outside. There's another pair of 2's, so that 2 will go on the outside. The 3 didn't have anything to go with it, so it will stay on the inside. So that 2 times 2 becomes 4. Square root of 3. And with a to the 9th power, again, we're basically dividing it by the index of 2. So if we divide 2 into 9, that's going to go 4 times with 1 left over. So again, we're going to need 4 a's on the outside and 1 a that's going to be on the inside. All right, and if you pull those two things together, you've got a 4 on the outside, you've got an a to the 4th on the outside, and then on the inside we've got a 3 and an a, so then that would go there. Okay, objective 6. Only thing different with objective 6, instead of giving you one variable, now they give you 2 variables. Still works the same way. Still just do it, one little piece at a time. So it's 2v to the 4th, x to the 5th, times 8vx squared. Okay, and again, still go through and do the exact same thing. It's 2 times 8 for 16. Don't forget there is a 1 with that v, so it's v to the 4th plus v to the 1st. That would be v to the 5th. X to the 5th and x to the 2nd makes that x to the 7th. Okay, and then just break it up one piece at a time. Square root of 16 works out nice because that's just 4. With the v's, again, index is 2, we're dividing 2 into 5, which will go 2 times with 1 left over. And with the x, still index of 2, so we're dividing 2 into 7, which will go 3 times with 1 left over. Again, everything on the top goes on the outside. Everything on the bottom goes on the inside. So the 4 was on the outside. We're going to have a v to the second on the outside. We have a x to the third on the outside. And then with the square root, we're going to have 1v on the inside and 1x on the inside. Okay, so even with the multiplication, if they give you more than one variable, you're just going to have, more than one variable in the answer. Just keep breaking them down. It's still the same concept. You're still just doing it one piece at a time. That whatever this index is, which I think every index so far with all these, as long as you've got variables, they're only going to make it square roots. So every one of these, you're always going to divide it by 2. So if it's an odd number, you're always going to know that you're going to have 1 left over. If it was third powers, you might have 1, you might have 2 left over. But just kind of keep going through those process there. Okay, objective 7. They use higher roots. But for this one, they don't do variables. This one, they just stick with the numbers. So in this case, now instead of everything has been square roots up to this point, now they start giving you third roots and fourth roots. Might even give you a fifth root along the way. So they may do something like this. They may give you the fourth root of 3 times the fourth root of 8. Okay, so you get the fourth root of 24. Okay, now, and again for this one, because it's the fourth root, you're looking for 4 of a kind. So if you go back and start breaking down the 24, now you kind of had it back here, right? Because you had 3 times 8. If you start breaking this one down, if you had 24, let's stick with the statement. If you take the 24 and start to break it down, you can divide it by 2. You can divide it by 2. You can divide it by 2. So it's 2 times 2 times 2 times 3. There's not 4 of a kind. You do get 3 of a kind here, but to break this out, you're going to need 4 2's. We only have 3. So if this one doesn't break down any farther and there's not 4 of anything, then that's just going to be your final answer. Okay, so let's give you one where it actually does break down, and you can break it down a little bit and go with it from here. So let's do the fifth root of 8 times the fifth root of 4. That's the fifth root of 32. Okay, now, and here's one where if the numbers are like this and the numbers are fairly small, you can also kind of, cheat just a little bit. Go ahead and break these numbers down. 8 is 4 times 2, which would then be 4 would be 2 times 2. So 8, if you think about it, is 2 times 2 times 2, right? If you do the next one, the fifth root of 4, that's 2 times 2. So if you lined up all this stuff and you took the 32 and broke it down, this would be the fifth root of 2 times 2 times 2 times 2 times 2. And there's your 5 2's, right? So that's the same thing as the fifth root of 2 to the fifth. And again, as long as this index matches that power, they cancel each other out, and your answer is just going to be 2. And we could have even done the same thing back here with this one. 3, if you break it down, it's just 3. 8 would have been here. It would have been 2 times 2 times 2. Well, if you break it down and there's not 4 of any kind, then there's just nothing you can do with it. All right, let's give you one more of those. Let's do the third root of 4 times the third root of 4. Okay, again, if you want to kind of cheat just a little bit here. 4 is 2 times 2. You got another 4, which is 2 times 2. So if you put all this together, you've got 2 times 2 times 2. You've got 4 2's. Well, we need groups of 3, so there's 3 2's that we can take out and put that one on the outside. That one doesn't have his exit buddies. He's there by himself, so he's going to stay on the inside, so that's going to be left with the third root of 2. Okay, so if they start giving you roots that are bigger than square roots, if they give you third roots and fourth roots and fifth roots, go ahead and start, and again, the numbers will be fairly small. Go ahead and start thinking about breaking those numbers down into your prime numbers, and then just pull all those numbers together, and then just pair them up, because, if you multiply them together, you're going to go back and just break them down anyway. So kind of go ahead and do that one. So with the bigger roots on that one, that's kind of where they're going. And to me, that's one of those that they could kind of just throw that at the end, because they put that in the middle and it messes up the flow of everything, because on objective number 8, they kind of change gears a little bit and go back. 7 to me was kind of a weird one. It's in a weird spot. They almost could put that in a different place. Because on objective number 8, it's going to have you go back and start multiplying square roots again, but this time we're going to use distributive property. Okay, still multiplication. We're still going to multiply the outside numbers. You're still going to multiply the inside numbers, and then you're still going to keep breaking them down. So this part to me was a little weird, because it just kind of messed up the flow with that last one back here. Okay, so if you have one like this, it may be the square root of 5 times 6 plus the square root of 2. Okay, and just remember that in front you have a 1, so it's 1 square root of 5 times 6, so 1 times 6 makes that 6 square root of 5. On the second one, when you multiply here, again, you got to understand 1 here, so it's 1 times 1, which is 1, which we don't need that. On the inside, you have 5 times 2, so you can make that square root of 10. And again, those are different radicands. So that makes them radicands, because if they're not the same, you cannot add them together. So that answer will just be what you're looking for there. Okay, and more than likely with distributive property, there's not going to be a whole lot you can do with these numbers, just because there's only the 2 terms, and they're going to be different here, because if these had both been, square root of 2's on the inside, well, then you would add them together. You get that? So more than likely, there's not going to be a whole lot with the distributive property problems that you're going to be able to do, because if you had like terms to start with, you would go ahead and just combine them down, and then you're not going to be able to. So good chance that you're really not going to do much with these problems. So for this one, let's go with square root of 7 times the square root of 2 minus 9. Okay, same thing. 7 times 2 is 14. And because these two are prime numbers, if you take 14 and break it down, it's just 2 times 7, so that's not going to help you out. When you multiply the second part, it's 9 times the square root of 7, so that'll just stay 9 square root of 7. Alright, objective 9 is just more distributive property. But this one, then they kind of bump it up and say, alright, well now that the numbers start to get a little bit bigger, you might have some stuff you can simplify. With the numbers we had before, they were all pretty small. We had one that was a whole number and one that was a square root. There isn't much you can do there. If you start getting more square roots, there's probably a good chance that when you start doing distributive property with these, you're probably going to get some things you can simplify. So on this one, you've got 9 on the outside. On the inside, it's 3 times 7 for 21. And again, those are both prime numbers, so if you take 21 and break it down, you get 3 times 7. It's not going to go any farther, so there's nothing you can do there. Okay, for this one, it's 9 times square root of 3 times square root of 5, which is square root of 45. That number big enough now, we can actually start breaking that one up. Because 45, you could do 3 times 15. But again, if you think about 45, it's 9 times 5. 9 is that perfect square root number, so we can make that at 3. So that's 9 times 3 times the square root of 5. So that would be 27 square root of 5. And we did have the 9 square root of 21 in the beginning. And for that one, that's as far as that one to go, because again, that's a square root of 21, that's a square root of 5. If they're different, you cannot add those two things together, so that one is as far as that one to go. Okay, and that's really the only difference between the two objectives. The very first couple problems on distributed property, there's really not much of anything you can do. As they give you a couple more of them, now you get some numbers that you can maybe break down one number, and one of them you may not be able to, so they'll kind of go back and forth on those. Let's give you one more of those. Let's go square root of 6 times square root of 10 plus square root of 3. Okay, so multiply everything by 6. Square root of 60 and square root of 18. Okay, both big enough numbers, you can start breaking those down. 60, there's all kinds of different ways you can go. And there's not a, we could divide it by 4, but it seems like there's something bigger we could divide out that's a perfect square root number, so we'll see what we can do. 60, if you divide it by 2, that's 30. 30, if you divide it by 2, that's 15. 15 is 3 times 5, so 60 is 2 times 2 times 3 times 5. You do have a pair of 2's you can take out. The 3 and the 5 are left on the inside. So that would be 2 square root of 15. Seems like you could get something bigger, but in that case, that's all you could do. Okay, square root of 18. That one, I know it's 9 times 2. 9 is that perfect square root, so that's 3 square root of 2. And because that one's square root of 15, that one's square root of 2, that's as far as that answer is going to go. Okay, last objective. Objective 10, they call it special cases. But this one, it's really special cases in full method. They talk about distributed property on the first two, and then they say, all right, well, this one's special cases. Well, then they forget to mention it's the full method. So, there we go. So it's 2 square root of x minus square root of 5. 2 square root of x plus square root of 5. Okay, now, here's what makes this one special when you get to these. We're going to do 2x times 2x. 2 times 2 is 4. On the inside, remember that if you do x times x on the inside, that's going to make it x squared. Now, here's what makes this one special when you do this one. If it's the same two terms, if this is 2 squared of x minus 5, this is 2 squared of x plus 5. When you do your full method here, these middle two terms are going to knock each other out, because this one you're going to do, this is going to be positive when you do this part of it. So it's going to be 2 squared of x times 5. That's going to be, on the old part here, that's going to be 2 squared of 5x. When you start multiplying this one, you're going to have a negative 2 on the outside and a 5x on the inside. So for this one, here's the special case on that one, that when you do this part, these two terms, because they're pluses and minuses, they're always going to knock each other out, because one's a plus and one's a minus. It's the exact same two terms. So for this one, you're really just going to do the flow method. Right? I'd say it, but you're going to do the first times the first and the last times last because the OI kind of knocks itself out there. All right, if you do the square root of x squared, that's just x. Square root of 25 is 5. So if you put all that together, it's going to be 4x minus 5. Because again, if you do 2 minus 2, that's 0 times the square root of 5x. If you do 0 times anything, that's just 0. So if you're doing 4x plus 0, 0 doesn't do anything, and then you kind of go from there. So again, special cases, when you see this one, it's always going to work out that way because the only difference here is that this one's going to be a minus. That one's going to be a plus. It's going to be the exact same expression, just different by that one thing. They call those conjugates. And if you multiply two conjugates together, the two middle two terms, the O and the I, always knock themselves out. And it just leaves you with the first times the first and the last times the last. Okay, and then the other special case one that they give to you is something like this. We have square root of x minus the square root of, let's not do 5, hang on. Let's do 5 back here, maybe. Let's make that a 7. Do something different. Okay, now here's one where people kind of get the temptation that they try to do the fluff method because they're like, oh, I'll just square the x and square the 7 and I got matched. No, because this is one you actually have to go ahead and think about it that it's square root of x minus the square root of 7 and then square root of x minus the square root of 7. So you actually have to go back on this one and then do the full method. Because a lot of people look at this and go, oh, I'll just take the square roots off, it's x minus 7. Well, it is, but you've got to go ahead and do the rest of it. So we're doing x times x, which would be square root of x squared. Minus, on the inside, we're going to do 7 times x to make it 7x. For this one, same thing. So we're going to minus 7x on the second part and then a plus 49. And again, I guess this is the difference between the two. If they were the different signs back here with the conjugates, these two signs always cancel each other out. The difference is here, they're going to be the same signs, so you're actually going to get to add these two parts together. Now, the square root of x squared is x. And remember, this is a minus 1 and a minus 1 here. So if you subtract 1 and subtract 1 of the same things, you're going to get a minus 2 square root of 7x. And then the square root of 49 would be